To solve this linear inequality, we can start by using the same techniques that we would use to solve a linear equation. To group the x's together, you could either subtract 5x from both sides or subtract 4x from both sides. I'm actually going to go ahead and subtract 5x from both sides. If I do that, then I could add 1 to both sides. So add 1, and then we have 4 is greater than or equal to negative x. So we're almost done solving at this point, but it's not considered solved until the variable does not have a negative in front of it. So what I could do to get rid of the negative is that I could either multiply both sides of the equation by -1, or I could divide both sides of the equation by -1. I'm going to go ahead and just write it as a division. So on the left, that leaves a -4, but now on the right side of our inequality, the negative x, when you divide it by -1, becomes a positive x. The reason I wanted to solve the equation this way is to emphasize a property of inequalities. You need to switch the direction of the inequality symbol. So the greater than part was towards the 4, and so now I'm going to put it in the other direction. So now the less than part, the closed part, is towards the left, or in this case, the -4. Solving any linear inequality is the exact same. All the steps would be the same as if you were solving a linear equation, with the exception of this rule here. Remembering that anytime you're in the process of solving, if you ever multiply by a negative number or divide by a negative number, you need to switch the direction of the inequality sign. So here we have one way to write the solution for this inequality. We could leave it like this, which if you read it is -4 is less than or equal to x. You might want to write the x first. So if we do that, it becomes x is greater than or equal to -4. So these two inequalities mean the exact same thing. And now let's go ahead and graph our solution. Whenever I graph the solution, I usually like to put 0 on our graph, and then I'll put points for any points, like in this case, -4 that we're dealing with for this inequality. And then I'll also add the negative infinity on the left side and the positive infinity on the right side. For this inequality, it's greater than or equal to. It's this or equal to part that means that for the graph, we could use either a closed circle or a bracket. I'm going to go ahead and draw the graph with the bracket notation. I'll put a bracket on -4 to indicate that -4 is included in the solution, and then shade to the right. Then I can also write the solution in interval notation. So the leftmost value is, in this case, a -4, comma, and the rightmost value, in this case, happens to be an infinity. The bracket stays on the -4 for either infinity or negative infinity. It's always a parenthesis. So for this problem, I have 3 representations for the solution for the original inequality.